To co, ja to usuń mnie może z tego.
Okay, hey guys, I think we're live. At least I hope so. Let me check if we are live. Okay, looks good. Okay, we're live. So welcome to the second lesson, live coding lesson with AskQL. I am the real code newbie here because I have no experience, no prior experience in coding. CSS, all that jazz, and I've just started to learn JavaScript like a few days ago. So you get the vibe. And now I'm learning AskQL. And with me is right now Martin Hagmeier, who is actually a creator of AskQL, one of two main contributors.
Hello, Marta.
So, hello. We're here together. Okay. And so in the first lesson, we learned a little bit of values and resources, right? We also created our first value, our first function, and we talked a little bit about syntax. So we said that different operations can be written in different ways. You can either use, for example, a plus sign, or you can use a word plus with a colon before. So it's basically, there are few ways to write the same thing. So it kind of, I think it means that AskQL is pretty flexible, right? It's human friendly, flexible, and there is no strict white space policy, so you can put spaces pretty much wherever you want to. So it works for me perfectly because I just, spaces, right? So it's always better when you have some of flexibility while you're writing your code, I think. But maybe that's not always a good thing, right? When you have so much flexibility. What do you think? What do you think? It's better to have this, not so strict white space policy, or is it better to just learn one way of coding? Why are here two ways of writing things? At least two ways.
Yeah. So I mean, white space adds complexity because I mean you are actually saying something with like having 3 tabs instead of 2 tabs, right? It's I mean, if a language is gonna require you to place 3 tabs. Tabs is basically like a space, but a longer one, and just has its own key on the keyboard. So I mean, so let's stick with spaces. Maybe makes it easier. So if a language was to decide if you're supposed to make 4 spaces or 6 spaces here, it would add a lot of complexity really to its grammar, and I think it would be just like sort of. I mean, you would need more space to explain the rules. Basically, what I'm getting at, right? So sort of more complicated in that way. So so when thinking about a language for AskQL, we're really trying to come up with something very, very simple and not really requiring you to make all of the styling. And also, it's sort of like the same in JavaScript. You can write a very ugly looking JavaScript code. I mean, definitely you can trust me on that. And you can also write code in JavaScript that looks quite nice actually. So it's the tool we use now. It's called Prettier, and what it does, it looks at your source file, looks at what it is, what it means, and creates a new source file, which has this really nice formatting for you, and it's gonna format the file the same way no matter who wrote it. So you can have the similar, quality and similar looking code across the entire project, just because no matter like what space someone uses, we all go through this Prettier formatting process, and the code going into the code repository is always formatted. So you see, doesn't really matter at this point. It's just like, I mean, it's not that big of a deal, the white space.
Mm-hmm. I don't know why I got so much into this white space policy. It's probably because I would always think that you have to think of where you're putting your spaces, because if you put it in the wrong place, then your whole thing is not going to work. So I was like, oh my God, I can put the space whenever I want to and wherever I want to. So it was like, thank you.
I mean, some couples can even break up over this. It's an important debate, like what kind of space you use and how, how much space does it take, right? Stubs or spaces, or like if spaces, how many spaces? It goes on and on. It's really just like spacing. It's not a matter of code. You see, it's more a matter of like spacing it on the screen. Doesn't really, for the code, it should not matter. Although programmers are like fun people a lot, and there are programming languages, actual programming language, just made entirely out of white space. So whatever you can write in this program, you're not gonna see, basically, because it's all white space. And there is like, I think like maybe like a few different kind of white space you can do in the character table, so you can use your pick.
Okay, well, that sounds like the next step for me. But so what we talked about last time was asking for values, and I remember that when we're asking for values that which are already assigned, I mean, so we are asking for a value, we are putting the name of the value, and then we get, for example, a number, right? So if I, for example, assign green dragon to the number 5, and I go ask for green dragon, then I will get 5 as a result. But we also talked about, so this is the value, just ask about the thing and you get the result. But we also talked about asking for resources, right? So
Marta, how about actually to make it maybe easier for everyone, especially for people joining in this current episode, to maybe bring up, mention the CLI that anyone can use even during the live session, and maybe show your examples a little bit there, so also it's easier for me to understand.
Okay.
Maybe easier for everyone.
Oh, okay, hold on. Let me share my screen then. Share screen and share, and let's go to the playground. Okay, so can you see my screen? Hopefully. Wait.
Yes.
Where are you?
I'm here.
Okay. So right here, we are asking for the value which for resource. We're asking for hi, right? And let's see what happens. We get hi, this is AskQL server, blah, 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 and the date, today's date, and the time. So that would be a resource because the program is asking for this, and this has to be operated in database, I believe, and this is the resource. So that's why we're having braces right here.
Yeah, it as you can see, this gonna return different value every time you run it. So it's not a value because it's pretty much different every time So it has to be like more going on inside, and actually this is an computation, like a resource. So you need to add those parentheses to have a place where sort of like where you can put the different like arguments to it. Yeah.
So this is our playground. If you could remind me, where can I check other values, things that already have names, or
so yeah, this we we've made some changes to the UI, also based on our previous lesson. So you can find this link on the right side under like available resources on the right side. It's gonna this is gonna list some of the things that you can. Yeah, I guess that's the first bug we. Oh yeah. Yeah. So basically, GitHub or like even the AskQL.org is a main our like main landing page, so we can start looking there for answers here. And also, like right here on the playground, you have these demos that you can sort of like look through. But it's not gonna like list the entire environment. It's just gonna give you some ideas about what is there. Yeah.
Okay, this. Okay, so we had ask hi, and we put braces here. We don't need this. So this is what we get.
Yeah.
And if we didn't have this, we would be asking for just for value, right? If there is some value assigned to hi.
Yeah, you can. The way you can look at it is like the hi it has different names, right? Depending on the context. So you can call it a resource, a function, a computation. The thing is like this thing is capable of producing a different value, you know, based on the circumstance, pretty much. So this is a different thing than a value that is already like computed. You see, like it has this difference. Like when I write 15, it always means the same thing. It's always 15. It's like a fixed value. But like resource it's like a value producer. It can produce a value. It can produce a different value every time based on its implementation. So yeah. So that's so this is why when you write hi and don't add these parentheses, you get this resource as a value, meaning that now you can pass it around. So if someone wants to get a resource of like specific for like specific purpose, then you can go give them the hi resource, and it would be a different thing that calling this resource, because you're not giving the value of calling it. You're giving this thing itself.
Okay, so what happened if we assign? Let's do orange equals 5, right?
Yeah.
And then we ask for an orange. Will that work? Yeah.
Yeah. Okay. So in your program, orange has always been a value, right? Because it was assigned the value of 5 at its creation, and then in line second, you sort of asked what the value was by referencing the name of the thing. And at the time, orange was a value, so you got the value.
Can we now go like this? What happens? Yeah, it works again. Okay.
Yeah.
Okay, so, but now we can change it, right? We can say from now on, orange will equal 7. So that should be 14. Let's see if it works. It works. Okay, yeah. So that I remember that. And we also talked about creating functions.
Yes.
So
Yeah.
It was. I remember it was. Let's just start from the beginning. It was like this, maybe. Why isn't it yellow? Was that yellow or not? Is it supposed to be yellow?
So usually what you would do, you would start with let, because you would want to create a identifier for this function.
So
what is the function that we're writing? What do we have in mind?
The name. Okay, let's do double. I don't know if I even remember that.
How about triple? We can.
Okay. Triple with double P or single P? I don't know.
Looks fine.
Should I can have an argument here, right?
This works. This works very much the same like with 5. Remember when you wrote equals 5? Now it's not equals 5. It's equal a different thing with the fun keyword. So you do let triple equals fun and curly braces. Yeah.
Curly braces. Do I put something in here? Or?
Yes, if you put something in here, we're gonna have a way to reference this first argument that goes into triple.
So I can put whatever and.
Yeah.
Sorry, I don't remember how to.
And now the curly braces, which gonna create a new scope for us where we can run this function. So pretty much, you add the curly braces now. Yeah.
Okay, right. And what do I? There was like $, 0.
So now you so in the scope you have n, which is the first argument to triple, and you're supposed to write a yeah. Okay, yeah, I guess so. I guess that makes sense. Usually you would need to write tests to show that it works in certain cases, but yeah, looks fine. Looks fine to me.
So what do I now? Do I say what is n or?
No. So the way you use it, you now have not. Yeah. Hold on, Marta. To make this easier, let's actually format the code a little bit here. So after every curly brace, let's make an enter, and let's add some indentation so we know that sort of like the stuff is separated. So so let's go line by line, and we're just gonna add a button to the playground that's just gonna format the code for you, making it simpler.
Okay.
But for now, let's just like, for instance, like, can you take a look at the GitHub, our GitHub? Yeah. And you scroll down a little bit. Yeah, and scroll down the diagram. Yeah. So there is, you can see.
Where's the diagram? Did I miss it?
I meant like even this graphic, right? If you click on it, it almost has good formatting, except for some parts we're fixing. But if you look at the 4, sort of like you see what's going on here. Like every line has, every like section gets embedded more, and you use the curly braces to sort of like see scope of these things, right? So that's sort of like the intention to use those. So like white space is not gonna matter for runtime, but it can matter for the readability of your code. So if you do it like this, it's difficult to know, oh, where does the code go after triple, right? Yeah.
Right. I'm not very used to this at this point, but
you yeah. Right. So in here, let's just delete that and start with saying triple in that line 5.
With a column?
No, just start simple. Just do triple. Let's not guess. Let's make experiment, but let's not be guessing, because like guessing is not gonna help us understand here. Triple. Okay, we got. All right. Is this something that you have just run? That's interesting. Shouldn't be like this. Let's triple. Okay. Let me see on. Let me see, because this. Wow.
Sorry. Would you like to share your screen and show us?
Yeah. Let me check. Right now, I just need to sort of write a similar program to yours and see if mine makes.
No,
I wonder why it would set that. Like, did you? Yeah. Are you sure made pressed run? Yeah.
I did, and now I pressed it again, and I got something else. But
write a similar program to yours and see. Yeah. All right. Yeah. Now that looks much better. Okay. So it seems like we were viewing at the previous result. Okay. So triple now is this weird thing that you see on the right side. So this thing is actually how this function is, how this triple is represented inside. So it just is like this triple is now like this confusing blob of information, not really important right now. What's important is that AskQL can understand it and it can use it to produce an answer for triple based exactly on the definition that you wrote up there. So let's try it out. We can write triple, for instance. Let's do with the parentheses. So you can, let's see what triple of 10 is, for instance.
Oh.
Yeah. So that's this is one way to use your.
So I just had a colon here for some reason, and I that's why I got this.
Oh, interesting. Yeah. So the colon you're only going to use after something. The colon here is gonna be after something. So if you use it, let's try 10 colon triple. So it's saying like I have the value of 10 and I want to triple it.
Yeah. Okay. Now I will just. Okay. Yeah. For some reason, I thought that if I put it this way, that would work, but it doesn't. So
yeah. All right. So Marta, let me. Are you ready to?
I'm ready.
let me ask you something. Something interesting here. So what would happen if in line 2, instead of n times 3, you said n times 5? How did that change your program?
Well, it would be multiplied by 5.
Yeah, and produce 50, right?
Yeah.
Okay. So how would you then name this function? Would that be okay to still call it triple, or would that just like not make sense?
By 5.
Yeah, nice. So then you would have like 10 colon by 5. Yeah. So as you can see, like we are always in the process of creating a programming language here, really, because we get to come up with our own identifiers and we get to use them in our programs, right? So it's very useful. It's just because if you in your project, if you have like specific definitions like greenhouse has meaning to you and stuff like that, then you can use it here and makes it easy to understand your program, even without like the idea here is if I take a look at by 5, I get what it means, and I don't need to look inside the by 5 definition to figure out what it really does. You see, that's sort of like the idea for the names. Okay. How about in line 2, instead of n times 5, we would say by 5. We would say n. We would just say like by 5n, or like yeah, let's try that.
Instead of, okay, let me just by just like this.
Yes, by 5 and colon n, parentheses n, right? Because so what we do here, we want to know what is the, so we are supposed to say what the by 5 of n, what's the value.
And it doesn't know yet. Does the program know? I don't think it knows.
So it's like if someone asks you, "Hey, what a tree is," and you point at the tree and say that, you know, and sort of like keeps going in cycle, you know, and doesn't ever produce an answer. Conceptually, you follow? Because it's like we are supposed to define what by 5 is, but in line 2, we just like refer to.
Oh yeah, so it comes back to this and asks what is it, and it's this, and so what is it? Okay, got it.
You want to run it? See what? Yeah,
that's how I got this.
So in AskVM, we're gonna have different limits that we are going to run into eventually, and that steps limit is a limit for a number of steps. So your program, with every computation, it has to make a certain number of steps. So the more you want to compute, the more steps you need. In that case, that computation would never like produce an answer, because it keeps like going through this by 5, doesn't really go anywhere. So it just run out of the steps limit here.
So how many steps do we have?
We have in this playground, we have 10,000 steps, which is currently equal to a couple hundred loops. So we're gonna, so you see, like it's like.
So if I'm pressing this run, in the meantime, it was run for like hundreds of times, and then I got the error.
I would probably like it run for I don't know, maybe 300 times, because like at this stage the language really isn't optimized for like heavy computations. It's more optimized for the networking aspect. So as we optimize it more, then it's gonna be more steps available to you. Okay. So we can figure it out. We can make it so that by 5 is only going to run for 300 times, and see if we run through the step limit or not. So we can be like detectives, you know, about this, and see how many steps we can make if you want. But like this is gonna depend on the program. Like the steps is not a good metric really. It's just the simplest metric you can use, and the additional limits that we're gonna have is gonna be like about the time limit. So you can do whatever you want, but it can take no more than like 1 second to produce an answer.
Yeah. Okay.
It depends on the host, because you basically let people run programs on your computer. So you want to set some rules about this, some limits, right? And this is one of them.
Yeah. Okay. All right. Cool. So what do we do now? Do we want to do some more examples?
Yes, that would be nice. So I have different ideas. Maybe there is something that you find interesting. If not, let's just like keep looking at things. I think it would be cool to dive deeper in this referencing itself thing. It's called recursion. It's an important subject in the functional programming languages. So we can talk about this a little bit. And it's also a very useful pattern for coming up with numbers, interesting numbers. So yeah, so we can do this, or we can just do whatever else is you think it's interesting about all this.
Yeah, let's do this. I have one more question though. It just came up to my mind. So whenever I'm asking for hi, right? And this is what I get. So is it defined that hi has to be answered by adding this text altogether with the time already somewhere in
Yes.
wherever?
Yes. So this computer that runs this AskQL, it is currently deployed on Netlify. Netlify is a server which runs JavaScript. So what we do here, we have like an AskVM, which is a JavaScript program that, a program in AskQL goes into it, and it runs this itself being a JavaScript program. So we create a virtual computer for AskScript, which itself is a JavaScript program. So the only way currently you can run AskQL is in JavaScript. So you don't need to know JavaScript because we have our own language, but it's just good for you to know that when you hear someone talk about JavaScript, that then you can use AskQL in that same place already. So I mean, and of course, like JavaScript has its different like libraries. For instance, you have a library to deal with what is shown in the browser. Node.js comes up with couple libraries, like with files that has to do with networking, that has to do with like passing data around. So you can, if you want to access those, like here you see we get the current date. Current date is what the JavaScript engine gives us. So we want to say, hi, this is SQL Server, but we also want to include that date, and that date is only available for JavaScript programs. So what we have here, we have a small resource. It's just like a very tiny bit of code, which now is this hi, and this hi is very simply says, I have a piece of text and I want to add the current date to it that comes from JavaScript. And that small bit is written in JavaScript, and it allows a lot of AskScript programs to be run using this hi resource. So the hi is like an integration, it's like a bridge between JavaScript and AskScript. It allows you to use JavaScript functions inside AskScript.
Okay, works for me for now. Okay, so do you want to share your screen now and show me some examples, or would you just?
I should be able to explain all of this to you while looking at your screen.
Okay.
And I like to see you type so much at the second lesson already. So that's encouraging.
Boom.
All right. So are you familiar with the factorial? What factorial is when we write like 5 exclamation mark?
It's 5 by 5 by 5.
I meant more like this is not something that AskScript understands. I meant more like in math function.
So it means 5 by 5 by 5 multiply by 5 by 5 by 5 by 5.
So what this means is it's a little bit different. It's like 5 times 4 times 3 times 2 times 1. So you go like backwards and multiply every new number.
Going from 5 to 1.
Yes.
Right. Yeah.
So factorial of 1 is 1, right? A factorial of 0 is also 1, but this is something that we just agreed about, and it fits very nicely into some other math. And so factorial about 2 is 2 times 1, factorial of 3, 3 times 2 times 1, right? And goes on. Okay, so we need to write a program that does it to make it easier to, like, let's imagine our task was, hey, what's the factorial of 10? And you didn't want to like manually do 10 by 9 by 8 by 7 by 6, because you don't need to do it anymore. You're a programmer, so you're gonna write a program that do all of this manual work for you and just gives you the answer. That's the idea.
Okay. So what do we do? Right?
Yeah, so first I would like to for you to sort of like come up with a general rule in your mind conceptually about factorial, what it is. Because when you start with a number, you want to say factorial of 10, right? So what it is? It's 10?
Yeah, it's going n. It's going n multiplied by n minus 1, which doesn't make sense because it won't know when to stop. So we need to go n and you go n minus blah, 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 blah. We need to write it down. I don't know. You need to like help me out. Oh, are you here? No, wait. We lost you.
All right. Okay. All right. So if you so you said one. So let's. This is important that we understand that we don't jump over it, and so let's take some time. So you said like factorial of 10. Let's start there. So you said it's 10 times what?
I was gonna say like from n.
Yeah.
So let's see, factorial from n.
Yeah.
Yeah. So it would have to be n times n minus 1 n minus 2 and so on. But it also has to know when to stop.
Yes, it only goes until certain number. Yeah.
So this is where I got stuck because.
So let's see maybe at a certain example, you know, how it goes down, because when you have like factorial 3, then you have 3 times 2 times 1, right? And then you need to stop, because if you didn't stop, then you would go times 0. That would not be good. So we only stop at 1, right?
Yeah.
Okay.
Oh. Huh. So there is like another condition. So you need to say and stop at 1. But how do we say that?
Yeah, we're gonna say that with a new instruction that we're going to learn. It's called if clause. It allows you to change the behavior of your program depending on the value at a certain depending on a certain value, basically. So if you want to stop at 1, we're going to be able to say, hey, if this is 1, then I want to stop. That's exactly what we're going to be able to say with this. So we're going to have this covered. Let's see how we can do this this process of going, at 1 by 1 by 1, like here. And let's think if we can use this recursion technique that we saw with by5 to figure this out.
Okay, so let's start from the beginning.
Right.
We're letting to be factorial. Am I going in the right direction, or?
Yes, definitely. You're gonna
factorial from n.
So as you remember, you can take a look at the previous function definition to sort of like keep that memory. So what we do here, we say let identifier. So you say factorial. So let factorial means I'm gonna create a new identifier in this word called factorial, and here is what it is. So you need to say the equals. So let factorial equals and
then function.
Yeah. Yes. So that function is gonna have. Is it gonna have arguments?
Yeah.
Okay. Cool.
Like so, this one.
Yes. Awesome.
And then I need this.
Yes.
Or no?
You do need those. Yeah, those are in every function definition. You need to place those so that AskScript knows what goes into the function and what doesn't.
So what now?
Seems like we always start with n times, right? So we can start with this actually.
N times, or maybe.
So let's let's maybe do right now n times 2, because we did that before and it worked. So maybe we can sort of start here and evolve,
Okay.
Okay, so maybe down there at line 7, we can write a small test, maybe see what factorial of 5 is, or like factorial of 3, because we know factorial of 3 is supposed to be 6, so we can keep checking if we got it right.
Factorial. Wait. How was it? Wait. Of 3. Was it like this?
Yes, I mean it's a matter of style. If you feel like it makes more sense to say 3 colon factorial, you can say 3 colon factorial, or you can say factorial and 3 in the parentheses. It's a matter of I mean, what language you like. Yeah, it can go both ways. Yep. Awesome. Okay, so what?
It should be 6. 6, right?
Yeah, let's run it. Yeah, it should be 6.
Oh, there you go.
yeah, that's pretty funny actually, because this is not the correct implementation. So let's try another test, maybe factorial of 4. What's that supposed to be?
I'm guessing 8. Yeah.
I mean, what is it really supposed to be? What's factorial of 4?
Oh, well, it's supposed to take 2 and multiply it by 1.
If factorial of 3 starts with 3, right?
Of 3. I was going with 2. Okay.
So factorial of 3 is actually 6, correct?
Yeah.
How about factorial of 4?
24? No, wait. 4 times 3.
Yes.
Times 2 times 1.
Mm-hmm.
So it's 24.
Yes. And what does our program say?
What does our program say? What does our program say?
8, not good. Fail. This test is failed. Okay, let's make it work. Let's make it work. So basically, our implementation has this problem that when we give it number 4, it doesn't produce the expected number of 24. We can call it an issue or a bug. That's sort of like a name you're gonna hear very often throughout your career at programming if you decide to go this way. So something that's to keep in mind, that we certain times we get to know some input data that our program is not work for some reason, and we those things are always gonna be there, just because programming is very complicated, and we just need to learn how to find them, fix them, and release them. That's basically what we do for maintenance of computer systems. Right. Yeah. So okay. So why is it not work? What do you think?
Because of this. We tell it take 4 and multiply it by 2.
Yeah. And what?
That's not what we want.
Yeah. How do you think? How would you fix it?
Well, just for this example, we have to take just for this sake, for this.
Yeah. Awesome.
Just in this case, it's gonna work, but it's not flexible.
Okay, but it's a step in good direction, I think, because it seems like this still we got a little bit more info. I mean, I feel like we got a little bit more going on, a little bit more thought has went into it, so it goes further. I think it's a little bit more similar to the definition, basically. Yeah. So right. So what next? What's your? Let's play detectives here. What do you think? I'm gonna help you if you need me.
I think
yeah.
I don't know. Like I don't know. We need that if. I think, but we also need to make this function be more flexible. So.
Yes. Okay, so let's do exactly that, what you said. So let's start with the condition. Let me show you how conditions work. So let's imagine that someone didn't know how factorial works, and they put in -4 into the function. What should happen then in our program? What do you think?
Here?
Yes.
Well, it's gonna do the operation by putting -4 in the places of n.
Yeah, and but what is supposed to happen? What do you think is supposed to happen when someone wants to know what is the factorial of -4?
Let's see.
Oh yeah. So this is the current result of our program. But like in math, most commonly you're gonna see just like that this operation is not defined. So let's say 4 - 4. So you can say, I mean, it's you could throw an error. Your program could like cause an error here, or we can use if statement. So let's say if someone gives us the negative value, then we always gonna just return 1, for instance, just as a because factorial of 0 is 1. So of minus number, it can also be 1. Why not, right? It's not defined anyway.
Okay.
So to do this, you very simply just need to, instead of above line 5, so at the beginning of your function, so you sort of like put,
Here.
Yeah, exactly. Give us a little space, and here you can say if. Yeah, and we need for if we need the braces. So you need to put this in the braces. Yeah, okay. And then you can go like.
Do I go like this?
Yes. Yeah, that would work. How do you know this?
I can't remember.
Yeah, it's a very common in programming languages. This means, do you remember what it means?
If n is 0 or less than 0,
yes,
then something happens.
Exactly. So, and then you need the curly braces again to say what's supposed to happen.
Mm-hmm.
So inside the curly braces, we want our function to return a certain value. So that returns means that instead of doing anything else, we're gonna return to whoever called this function, and we're gonna give them the value, and we're not gonna do anything else. So you can just say return 1 here, right? Because that's what we agreed.
Do I put equals or just
space? Yeah, just space like this. This is what, so that if bit and return is exactly like JavaScript does it. Just so you know. So you know that already. It's gonna look familiar to you if you look at it. Yeah. So let's run it now and see what results we get. 1. Okay. Makes sense, right?
Yeah, because all of the ends are 1.
Okay. Right. Cool. Let's do some more investigation. Let's see what bugs do we have. Does it work for 0, you think? Does it work for 1, and so on?
It should be 1 as well. Yeah.
Okay. So can you find a bug? Is there a bug?
Is there a bug?
Well, that doesn't look right. Factorial of 1 should be 1. Why do you think that is, that we get 0 here?
Because of this.
Yeah. How do we not go like here if we have 0, 1 already?
Because we said that happens in case of n. When n is 0 or below, less than 0, but here we have this compute operation.
Yeah. So in line 8, we know already that n is positive, because if it wasn't positive, then we would never be here, because we would return, right? So on line 8, we already know that n is positive. So we have the positive number, and we multiply it by a number 1 less than it. So if we start with 1, we multiply it by 0.
Okay, so what do we do? Like, what do we write?
It has to do with the what would be very useful for us right now would be to say something like factorial, something like 10 factorial of 10 is 10 times factorial of 9, sort of, because then we would say factorial is this thing when you multiply another number to it. You see, you have factorial of 3, and now you want to know what is factorial of 4, so you multiply a number to it. So going opposite direction, you can say, oh, I have factorial of 10, and what it is 10 times factorial of 9, because if I had factorial of 9 and I multiplied 10, I would get factorial of 10. So it has its whole sort of has this similar nature like by 5, which was also has, been defined by itself.
Mm-hmm. So we have to change this.
Yes, this is what gets run for positive ends.
So I don't know. What should I do now? Just tell me.
What is this that you wrote in the line 11? Let's figure it out.
Just a comment, but isn't it? If I put it here, it's gonna get looped, right?
Yes.
But should I put it here?
I mean, you can always try and see what it does, and then try to understand the result. You're gonna do a lot of such experiments to see. Yeah.
Real line, and it should just run out. Yeah.
The reason why this runs out, I think, is that you always ask for factorial of 9, and you keep asking the same question. You see?
Yeah. I'm asking. Yeah, I'm actually asking for run this function, and then it starts all over again. So
yes, because it runs with the same argument. If you run the function with the same argument, you're always gonna get the same result. You're not making this problem smaller. You're just asking the same problem.
Yeah, exactly.
Yes. So let's maybe use n somewhere here, and let's maybe not use 10, but let's use n.
So like here.
Yeah.
Like this? I don't know.
Yeah, neither do I. Let's try it, figure out what it says and why it works.
Oops.
Oh, okay, that's interesting. We got a large number. I don't know. Maybe let's play with this a little bit more and sort of like understand what it does. Okay, that gets
works for free. That looks good too.
Yeah.
What if we put 1? Oh. Okay.
Yes. So how about factorial of 5? What do you think should be the factorial of 5?
Well, 5 times 20 times 60 times 2, 120. And that's it.
Okay. Why does it work, Marta, here? That's the question. Yeah.
I actually thought it would get looped as well, but it doesn't. So it says 5 times factorial from 4, but then okay. At least okay. So it runs over and over till it gets till n is just 0, and then it stops, right?
Yes.
Okay, makes sense. Yeah.
Awesome.
Cool.
Awesome. That's a very, recursion is a concept that at the beginning of the computer science studies, a lot of people get headache about, and one of those concepts in computer science. So happy we got to cover it with functional programming languages. It's important to know this trick, because as you can see, you can already write programs that automate a lot of manual work, because you just you can define a function and you can reference it, right? So you have a function defined and you can say, I now want to use this function that I defined to compute it. And you can even do it inside it already.
Okay. It's you have to get used to it, because it's just, when you look at this, you think, no, it's going to get looped because you're asking within the function about the function again, and how in world it's not going to get looped, right? But then also you have this and you go like, okay. But it's now it's understandable for me.
So this shouldn't get looped, and you understand why, right?
Now I do, but not when we were creating that. It was like, I wouldn't, at this point I wouldn't come up with an idea like this.
Makes it easier with practice to figure this one out. And I mean, funny enough, this is not. This is perhaps not the. This is not the only way to do it, and we're gonna learn other ways to do it as well. But just wanted to start here because this is something that you can write on your own already. It only uses the constructions that we learned, the functions that we learned over 2 lessons. So, I mean, yeah. If you just wanted to find out what is factorial of 12 or something like that for your own, then now you can, and just we're gonna work on some more complex computations as well.
Okay, let me just stop sharing my screen and we're back. Okay, so we're running out of time right now. I'm just checking if there are any questions, but not really. So yeah, that was fun. I hope you guys had fun as well, at least, because you were watching me struggling. But no, it's actually a lot of fun. So I hope we're gonna keep learning, and you are all invited to join us and learn with us. Right? What do you think, Marcin?
Yeah, that's always exciting. I think to see that you move so fast really here with those things and those constructions. I hope the audience can pick up. There's a lot of stuff that we have yet to talk about, and I think that we didn't stream on YouTube our first lesson, but starting with this one, we are doing this, and we also gonna add some descriptions to help people understand what the lesson was about and what were these different sections inside that lesson. So I think it's gonna make it easy for everyone, even if someone only has like a couple minutes to look this over. And
we're gonna make you guys a little handbook. So if you want to just come back to the examples or see the code, or just if in case you are more of a reader instead of listener, or if you want to read and not watch me trying out things, then you will have that also at your disposal. So
I also wanted to sort of like point out that currently we only use with very simple values, like some numbers, some text. As you can see, the programs that Marta wrote, they also produce text pretty much that what happened about the computer. We just received some text with the answer. We are going to, in these lessons, cover another formats of results. You can have your program create a website, so you can see this website as a result of running your program, or like an image or things like that. So it's really like we open up I think a very rich chest of fun exercises here.
Mm-hmm. So guys, if you want to practice in the meantime, go to our playground, check out the demos, check out the examples, and if you have any questions, just let us know here on Facebook, on Twitter, on Discord, or pretty much wherever you want to. We are there. We are available for any of your doubts and questions. And yeah, if you want to just learn more, and if you want to stick with us. We're going to have more lessons, and we're going to learn new things. So I'm excited. Hope you're too. And let us know if you have any thoughts on our project from AskZero to AskHero. And in case you have any questions right now, let us know. We are still live streaming on YouTube, but I don't think there are any questions at this point. We have smiley faces, so thank you. Thanks, guys, and see you on Monday at 6 p.m. In a week, next week, right?
Right.
Okay.
Thanks.
Thank you, guys. See you later. Bye-bye.